Today we are going to study about balancing redox reaction in acidic medium. The rules for balancing redox reaction. Number 1. Find the oxidation number of all the atoms in the reaction. Number 2. Find out what is oxidized and reduced. Number 3. Write the half equations that represents the oxidation and reduction. Number 4, balance both reactions for all elements except oxygen and hydrogen. Number 5, balance hydrogen and oxygen by adding H plus or H2O to the appropriate side. Number 6, balance the charge of each half reaction by adding electrons. Number 7, multiply the coefficient of each half reactions so the same number of electrons appear on both sides of the equation. And finally, add the two equations to cancel out the electrons. The equation should be balanced. Now let us understand it by looking at an example. The example is MnO4 minus plus S2O3 2 minus Mn2 plus SO4. Let's first write down the equation. MnO4 minus plus S2O3 2 minus will yield Mn2 plus SO4 2 minus. Now the first step is find the oxidation number of all the atoms in the reaction. If you're not familiar with the oxidation, finding out the oxidation number, you can watch some of my previous videos. Now, oxygen in MnO4, oxygen will have a charge of minus 2. Manganese therefore will be plus 7. S2O3, oxygen again here, minus 2, and sulfur will be plus 2. So they'll have overall charge of 2 minus. Manganese over here, overall independent, so we can just write plus 2. And here again oxygen minus 2. And therefore, there are 4 oxygen, therefore sulfur will be plus 6. Now, once we have found out the oxidation number of all the atoms in the reaction, we'll move on to find out what is oxidize and reduce. Now, if you look at sulfur, if you look at S2 in the reactant side, it has an overall charge of plus 2, whereas in the product side, it is plus 6. So we see that it has lost 4 electrons. So S is oxidized and loses 4 electrons. Now when we look at Mn, it's plus 7 in the reactant side, and in the product side it's plus 2. So Mn is reduced because it gains 5 electrons. So we can write it down. Mn is reduced and why? Because it gains 5 electrons. So now we know that sulfur is oxidized and manganese is reduced. Now we can write down the half equation that represents oxidation and reduction. So let's write it down. So for oxidation, S2, we can leave a little space for the other. Yeah, so S2O3 2 minus will give you SO4 2 minus plus 4 electrons. Why do we write 4 electrons? You see here that S is oxidized and loses 4 electrons. Now for reduction, second half reaction equation, TiON. So for that, it's MnO4 minus plus, here we have 5 electron. Why did we write 5 electrons? Because Mn is reduced and gains 5 electron, which will yield Mn2 plus. So there is your half equation that represents oxidation and reduction. Now balance both reactions for all elements except oxygen and hydrogen. So we first of all take the first equation, that is S2O3 2 minus will yield SO4 2 minus plus 4 electrons. Now in this equation we will first of all balance for sulfur, because we don't have to balance oxygen and hydrogen. So let's balance sulfur. So what do we see here? There are 2 sulfur and there is 1 sulfur over here. So let's put a 2 over here. So now we can see that sulfur is balanced in the oxidation reaction. Now let's move on to the reduction reaction. Let's write it down. MnO4 minus plus 5 electrons will yield Mn2 plus. Now here again we see there is Mn and 1 Mn both the side. So it's already balanced. Now let's move on to the next. Move down to rule number 5. Balance H and O by adding H plus or H2O to the appropriate side. So let's write down the equation first. S2O3 2 minus will yield 2SO4 2 minus plus 4 electrons. Now let's count the number of oxygen both the side. So we can put L for left side and R for right side. So left side, how many oxygen are there? We'll see there are 3 oxygen. And right side, 4 into 2, 8 oxygen. We need to balance the oxygen on the left side by adding 5 H2O. So let's do that. S2O3 2 minus plus 5 H2O will give you 2SO4 2 minus plus 4 electrons. So now we have balanced the oxygen. So both the side we have 8 oxygen. So now we are left with the hydrogen. So let's see how many hydrogen are there in the left side and the right side. So left side we have 10 hydrogen, and in the right side we don't have any hydrogen, so we can write 0. So let's write down the equation now. S2O3 2 minus plus 5 H2O will give you 2SO4 2 minus. Now we add down 10 plus 10 H plus to balance the hydrogen, plus 4 electrons are there. So now this is balanced. The charge is balanced. Now we are left with reduction reaction, and that is for MnO4 O4 minus plus 5 electrons will yield Mn2 plus. So we first start by balancing oxygen by adding H2O. So let's see the left side and then the right side. Left side, how many oxygen are there? There are 4 oxygen. And right side, there are no oxygen. So we have 4 oxygen on the left side and 0 oxygen on the right side. So we add 4 H2O on the right side so that 4 oxygen will be balanced from both the side. So let's write it down. MnO4 minus plus 5 electrons give you Mn2 plus, and then here we will write 4 H2O to balance the oxygen. Now let's look at the hydrogen. Left side we have left side we have no hydrogen, and right side we have 4 to the 8, we have 8 hydrogen. So in order to balance the 8 H2O, 4 H2O into 4 into 2, 8 H2, we have to add 8 H plus on the left side. So let's do that. Plus 5 electrons will give you Mn2 plus plus 4 H2O. So we have balanced it. Let's move on to the 6th rule. Balance the charge of each half reaction by adding electrons. So now we have to balance the charge of each half reaction by adding electrons. So let's first of all write down the equation. S2O3 2 minus plus 5H2O will give you 2SO4 2 minus plus 10H plus plus 4 electrons. Now let's put the overall charge. S2O3 2 minus will be having a overall charge of -2. 5H2O here is the independent individual compound, so it will be 0. 2SO4 has a charge of 2 minus, but overall 2 it is, so 4. Overall it will become 4 minus 4 charge. 10H plus will have a plus 10 charge, and electrons over here, each electron, one electron is -1 charge, so 4 electrons will be -4. So now we have balanced the electron. Now we have to count the total charge on left side and right side to see if the number of charge, we have to balance the charge by adding electrons. So see the charge are equal to the right or left side. So let's do that. So left and right. So let's count the left side. What's the charge? So we have overall charge of -2 on the left side, and right side we are having a overall charge of +2. -4 -4, that's -8, and +10, so +2. And the left side we have -2. So we add 4 electrons to the right side, so we'll have 8 electrons, so charge will become balanced. So let's write that down. I hope you're following me now. S2O3 2 minus plus 5 H2O will yield 2SO4 2 minus plus 10H positive plus, now this 4 electrons we have to make it into 8 electrons to balance the charge by adding 4 more electrons. So now it becomes 8 electrons. Now let's look at the other equation, the reduction equation, that is MnO4 minus plus 8H plus 5 electrons will give you Mn2 plus 4H2O. So let's see the overall charge on each. MnO4 has a charge of -1. 8H plus have a charge of +8. 5 electrons again, each 1 electron and -1, so 5 will be -5. Mn has a charge of +2, and water over here, H2O, has no charge because the individual compound over there. So let's see the left and right side, the charge, overall charge. Left side is 8 and -6 and minus, so that is 6 minus, so it will be +2 will be remaining. And the right side we have +2 only, so +2. So it's already balanced now. So the charge of each half reaction is balanced. Let's move on to the next step. Now the next step is multiply the coefficient of each half reaction so the same number of electrons appear on both the sides of the equation. So let's first of all write down the equation. S2O3 2 minus plus 5H2O will yield 2SO4 2 minus plus 10H plus 8 electrons. And the other half equation, that is MnO4 minus plus 8H plus 5 electrons will yield Mn2 plus 4H2O. Now if you look at it, you'll see there are 8 electrons in the first equation and there are 5 electrons in the second equation. So we have to balance this equation. So what we can do is we can multiply the first equation by 5 and the second equation we can multiply by 8. So then the number of electrons will be equal. 8 5s are 40 electrons and the second one 5 8s are 40. So then both will be balanced. So let's write down the final equation. So 5 multiplied by this equation will be 5 S2O3 2 minus plus 5 5s are 25 H2O will yield, here it is 2SO4, so 5 2s are 10 SO4 2 minus plus 10 5s are 50 H plus, and finally 5 8s are 40 electrons. So we have 40 electrons. The next equation we have to multiply by 8. So 8 MnO4 minus plus 8 8s are 64 H plus 40 electrons. Now this also gets 40 electrons. You can write it more clearly. 40 electrons will yield 8 Mn2 plus 4 8s are 32 H2O. So now we have multiplied both the side and now the electrons are equal. Now we'll move down to the last procedure or the process. Let's move on. Now add the two equations to cancel out the electrons. The equation should be balanced. So this is the final step. So let's write down the equation neatly. 5 S2O3 2 minus plus 25 H2O will yield 10 SO4 2 minus plus 50 H plus 40 electrons. That's the first equation. The next equation, 8 MnO4 minus plus 64 H plus 40 electrons will yield 8 Mn2 plus 32 H2O. Now we will add the two reactions. Let's add it up. So let's write it down. We can use red this time to add it up. So 5 S2O3 2 minus plus 25 H2O plus 8 MnO4, that will be minus over there, plus 64 H plus will give 10 SO4, this one, 2 minus plus 50 H plus 8, this one, 8 Mn2 plus this one, 32 H2O. Now let's cancel the similar terms. 25 H2O and here we have 32. So we are left with 7 H2O. Then we have 64 H plus and then 50 H plus. So we are left with 14 H plus. Now let's write down the real final equation. You can use a blue color over here. 5 S2O3 2 minus plus 8 MnO4 minus plus 14 H plus will give you 10 SO4 2 minus plus 8 Mn2 plus 7 H2O. So this is the final balance equation. After the whole procedure, we get the final balance equation. So it's a lengthy procedure, but it's not difficult. It's possible to do it. The next video we will be doing balancing the redox reaction in basic medium. I hope you have understood this.